Begun in 2007, the Science and Technology Roadshow, organized annually by the Department of Science and Technology, National Capital Region, involves representatives from the media, local government units, partner agencies, and setup beneficiaries for micro, small, and medium enterprises. The main objective of the activity is to showcase the programs and projects of the department for MSMEs and LGUs. Specifically, the roadshow aims to show the public and MSMEs how science and technology interventions can improve the production, operations, and services of the company. The two-day roadshow started with a visit to the Styroplastic Densifier project located in Payatas, Quezon City. The Styroplastic Densifier project is a collaborative undertaking among the DOST-NCR, DOST-ITDI, and the Quezon City Municipal Government. DOST-NCR designed the Styroplastic Densifier project, which aims to recover and reprocess waste styrofoam and plastic bags being dumped in Payatas, as well as provide community-based livelihood for the grassroots living in the vicinity. The project was implemented in coordination with DOST-ITDI and Quezon City LGU. It aims to install and operate ITDI-developed densifier at Payatas, provide technology trainings for the operators of the plastic densifier, and promote marketing of the products of the technology. The DOST-NCR and DOST-ITDI have provided livelihood to 1,000 members of the Buklod Lakas ng Scavengers Ini, or Bulasi, in Payatas, Quezon City. DOST tapped the Bulasi to provide the raw materials for the Styroplastic Densifier project. Here, waste styro or plastic are bought on a per-kilo basis. Solving the problem on solid waste in Metro Manila and other urban centers in the country remains a worsening problem each day. According to studies made by the National Solid Waste Management Commission Secretariat of the Environmental Management Bureau, or EMB, a person living in the metropolis produces about 0.56 kilograms of waste each day. With an estimated population of 11 million, the total waste generated in Metro Manila alone could run up to 6,160 metric tons per day. Translated, that would be 184,800 metric tons per month, or 2.22 million metric tons per year. Approximately 56% of these wastes are biodegradable, while 44% is non-biodegradable and mostly recyclable. Recycling and composting accounts only to 720 tons per day, or roughly 11% of solid waste generated in Metro Manila, due to non-segregation, unavailable recycling technologies, and the limited market for recyclables. At this rate, we might soon find ourselves buried in our own trash unless something is done. Remember the tragedy that happened to the residents of the Payatas dump site in Quezon City. When its mountain-high garbage collapsed, it buried garbage scavengers in its course. This tragedy opted us to strengthen our resolve to do solid waste management. Thus, the DOST-ITDI developed technologies on solid waste management, which is simple, affordable, environment-friendly, and able to generate livelihood. One of the technologies developed by DOST-ITDI is the plastic densifier, a plastic recycling technology which converts waste styro or plastics, especially foam polystyrene and plastic bags, into useful products such as tables, chairs, catwalk blocks, boards, bricks, synthetic timber planks, plastic planters, and a lot more. And so, in response to the directive of the President to come up with a livelihood program and doable pro-poor projects that will employ lower middle class and the poorest families in the region, the DOST-NCR formed a collaboration with LGU Quezon City and with DOST-ITDI to work on a livelihood project and at the same time respond to the various solid waste problems of the city, particularly in the Payatas dump site. Waste characterization data was collected by sorting the waste into material types like newspaper, plastics, styrofoam, aluminum cans, etc., and weighing each type. The waste samples were taken from 5 trucks delivering waste to the Payatas landfill. The waste characterization information was designed for solid waste planning. However, anyone interested in the characteristics of the solid waste stream may find it useful. Local government planners, haulers, and recyclers may estimate the amount of certain materials in their waste stream through the Waste Characterization Database. A major part of the waste characterization information helps the LGU understand what is in their waste stream, a first step in devising ways to reduce waste and cut disposal costs. The process is as follows. First, plastic wastes are collected and sorted. Next, these wastes are reduced by grinding or crushing. The shredder or grinder is used to grind recyclable waste such as plastic sandbags or polyethylene or polypropylene, styrofoam or styrofoam, high-density polyethylene, PET bottles, trays and containers, aluminum foil packs like sachets and pouches, polyethylene and polypropylene household plastic wares, and other commodity plastics. Then, the waste materials will undergo inspection or batching. This is where weighing and charging happens. In this step, the ground waste materials are weighed and charged into the plastic densifier. The pre-weighed used cooking oil is heated to a controlled temperature. Afterwards, melting or densification takes place. Grounded or shredded post-consumer waste plastic sandbags or styro are melted in a preheated used cooking oil at 150 degrees Celsius with continuous mixing until a homogeneous melt is obtained. In this process, the pre-weighed waste plastic is slowly added. For purely polyethylene plastic waste, 1:1 ratio with the used cooking oil is done. For instance, 20 kilograms of polyethylene goes with 20 kilograms of used cooking oil. For mixed plastic waste materials like polystyrene and polyethylene, the waste plastic mixture is in a 2:1 ratio before it is combined with the used cooking oil. Lastly, the resulting molten waste plastic is then easily molded by casting into the metal molds, which display potential uses for tabletops, planters, blocks for pathways, floorings, and other valuable functional products. These products can now undergo finishing work such as fabrication, grinding, cutting, painting, welding, and assembly. The general objective of the project was to create a community-based livelihood project for the poor families residing near the Payatas disposal facility and to respond to the solid waste problem in the Quezon City Controlled Disposal Facility. Specifically, it aimed to install and operate DOST-ITD identifier at Payatas, Quezon City, provide technology trainings for the operators of the plastic densifier, and promote marketing of the products produced from the technology.